Have you ever found yourself pondering the nature of a warp engine or if it's even feasible? Well, let's dive right into it. A warp engine, in simplest terms, is a hypothetical method of faster-than-light space travel. Imagine a spaceship that doesn't move through space but instead moves space around it. Sounds like something straight out of a science fiction novel, right? Well, it's no surprise that warp engines have been a staple in sci-fi narratives, from the iconic Starship Enterprise in Star Trek to the Millennium Falcon in Star Wars. These stories have not only captivated audiences for decades but have also inspired real-world scientific inquiry. Yet, as fascinating as these concepts are, they remain firmly in the realm of the theoretical. Warp engines hinge on bending space-time, a concept that's as mind-boggling as it sounds. So, in theory, a warp engine bends space-time to allow a spaceship to travel at superluminal speeds, but is it possible? To understand if warp engines are possible, we need to delve into some science. Let's start with the concept of space-time, a four-dimensional fabric that includes 3 dimensions of space and 1 of time. This is a central idea in Einstein's theory of relativity, which posits that gravity is not a force, but a warping or curving of space-time by mass and energy. Now imagine a warp engine. In theory, it would contract space in front of it and expand space behind it, creating a kind of warp bubble. Within this bubble, a ship could ride the wave of space-time, achieving faster-than-light travel without actually breaking the cosmic speed limit. The ship isn't technically moving, space itself is. But remember, this is all hypothetical. Despite the fascinating theories and tantalizing possibilities, warp engines are not yet proven. The science is still largely speculative and untested. Now that we've got a grasp on the science, let's explore why we haven't seen warp engines yet. Creating a warp engine isn't as easy as it sounds in science fiction. Theoretical roadblocks are a major hurdle. The concept of a warp engine hinges on the idea of negative energy, an abstract concept that, to our current understanding, only exists in the realm of quantum mechanics. It's a far cry from the tangible, physical resources we use in modern engineering. Practical challenges add another layer of complexity. Even if we could harness negative energy, the sheer amount of power needed to warp space-time is astronomical. We're talking about energy levels equal to the entire mass of Jupiter, converted into pure energy. To give you an idea, that's billions upon billions of times more than what humanity currently consumes in a year. Our present-day technology and understanding of physics just aren't equipped for this kind of task. It seems like a warp engine remains a distant dream, but what does the future hold? Though warp engines are currently just a theory, the future might surprise us. In the realm of scientific research, nothing remains impossible for long. As we speak, numerous studies are pushing the boundaries of what we know about faster-than-light travel. While the concept of warp engines remains a distant dream, the rapid pace of technological advancement could soon turn this dream into a reality. A prime example of this ongoing exploration is the Alcubierre drive. Named after the physicist Miguel Alcubierre, this concept hypothesizes a method of bending spacetime in a way that allows for faster-than-light speeds. Although currently limited by the constraints of our understanding and resources, this concept represents the endless possibilities that the future might hold. The path to warp travel is filled with challenges and unknowns, but with every scientific discovery, we're getting one step closer. So, while we can't pack our bags for a warp speed voyage yet, who knows what the future of space travel might bring?